Next up, we have Glacier Bohm, the first contributed talk. And chasing cosmic rarities, so anomalies.
Okay, can you hear me? All right. So thank you for the organizers for having me. My name is Clécio Nebon. I work at the Brazilian Center for Physics. I'm sorry, it was cutted, but I'm head of the AI laboratory there in this beautiful city of Rio de Janeiro, where the last NAD meeting happened, like you just heard, right? And I'm going to talk a little bit of our work in AI and how we see a perspective of dealing with so many alerts and so many interesting trends and insights using agentic AI. So we are this team working on this specific projects. I forgot to add three new acquisitions, which are Eduardo, Claude, and Gemini. But decide on that, these are the people involved in the work right now. And the idea is the following. So usually this is a very general way of seeing how we do science nowadays. So we have this alerts from the telescope, we have the brokers, they can filter, we can use them to classify or use our own classifiers later on. So there's decision for follow-up, and then we do our science, right? So this idea is what I call the classification centric. You classify stuff, and then you make a decision and move forward, if you like, which is great if you can have a look on everything and have a big picture of everything. But what we see now is we're not going to be able to have a clear picture of everything that's going on. So that's the whole point of changing the way I see the problem, at least. So what we propose in our framework is to have an AI as assistant, right, in several steps. So we are building this platform and these algorithms based on foundational models that can make a quick assessment of what it is after the classification and ask for our agentic AI to help us make decision and reasoning over what we see in the skies. So we would have informed decisions with arguments and debates between the agent, whether this is an event with how rare it is, how novelty this looks like, how extreme it is compared to others I'm seeing in the population level. This could be resolved by follow-up or just photometry. What are your recommendations for tonight for resolving this object, right? And then we feed everything back and forth until we are satisfied. So once I wake up in the morning, I already have reports with everything. It seems like an interesting science opportunity. The idea is to have science-driven questions over here to make informed decisions. Right? So how do we do this, this idea that I just posed to you? So our approach is based on working on foundational models, which are large pre-trained multimodal models that can deal with several different kind of data, like spectroscopy, catalog level, magnitudes, and host information and everything all together squeezed in a single model. All right, it can replace many task-specific models, can exploit unlabeled data, and make a quick transfer learning across several domains. So that's the base idea on make a quick assessment over the data before the agentic works on. So we are building this API structure inside this platform that we call AI Scope, where data lives. And we are producing APIs for several open foundational models that are in the literature, including one is already in production, which is this one, a 3 billion parameter, and the others are on the way. right? And to integration with the agentic AI that we call Whisper. Okay, and what is Whisper and how it works? So the basic idea is a system that can learn for whatever data it is cross-matched, including everything that you can see. So from catalogs, in the moment working on the legacy survey catalogs, also the streams and cross-match between streams between ZTF and roaming alerts whenever available, and your own personalized data that you can upload from follow-ups, and make analysis, right? Make fast modeling. How can we do that? Well, we can use, as we now are using, approximate Bayesian computation, SBI, and other fast assessment techniques to have an idea of the object and make recommendations. And forecast. So look at this object the next 2 nights, and you might resolve the parameters for a given model. So that's the kind of questions. If I observe one more epoch with this telescope, will I be able to resolve the correct model? On which band? Which limiting magnitude? So that's the assessment that Whisper should do, and is already doing at several levels. So the agent that we are building, is already a working version of it. It builds upon graph knowledge representation over the whole archive history. We didn't reach to the whole archive yet, but we are getting to the bottom of it because we're going from the present up to the past, right? And the last years are, as you know, where we have most of the papers going on. So there is a huge work on making this useful retrieval knowledge, and then the idea is to have this natural language interface with reasoning and justification on what the model sees and what was the fast assessment over this for a given object, right? So you can adapt for a given scientific goals, and check for anomalies and whatever he finds it interesting or a good science opportunity. You just need to code this in a way that the engine will look for, right? So now most of the models we use are based on Redback, right? Which make this fast analysis. It is 3 different ways as a per choice of the user. So we can use approximate Bayesian computation, SBI, and MCMC. Well, we only use MCMC when needed be, right? Because we know it's very hard to scale. But with the infrastructure we have, we are aiming to scale to up 1 million of runs very soon with these other 2, right? So this part of this work is already published in several papers. So this is just one of the example of it, where we were using a neuroposterior estimation in the NeoRIPS paper recent over the kilonova GW170817. We already applied this also to other GRB, the 230307, right? With also with SBI. The full MCMC model comparison over this platform was also applied to this GRB to see which of the models are best represent the data, right? With a very nice conclusion, as you can see here, where you could also constrain the mass of the merger, and also the LLMs can point it out what are scientific interesting opportunities. But this is one example earlier this year, already accepted to APJ letter, where the LLM could point us out. This is a very rare and extreme situation of offsets. I mean, it's one extreme offset for a kilonova for this event, GRB 230307, aka my wife's birthday, which was exactly this day. And we could make a full modeling over the galaxy and the BNS population and see this is a really streamer. Only 0.6% of the binary merger model population could explain so far away offsets assuming that it was the binary was formed in the disk of the galaxy. So also something that the LLMs can help us for is among a lot of data and a lot of hosts hard association, what are the opportunities? So this is one opportunity to understand how rare and unique is this event. Also, this platform with the photometric redshift that we produced with the ingestion of GW data helped us a lot in several papers, including this from last week, which are current constraint over H0 using dark science, where we could reach a 6% measurement. So this multi-platform is already operating in use and giving very nice results, right? And if you want to check it out, just take a look. So the idea is to enable AI to accelerate our size. This open version is not fully powered, as you might see, but you can already discuss with the LLM. There's a prompt here. You can make a discussion over what the data is in the site. If you want to see the full version, which is now only for stress tests, just let me know. I can open that to you. The idea is to build a community that can take advantage over these AI agents and this other way of viewing the problem, right? So this is only possible because, well, as a head of AI lab in Brazil, we develop our own HPC technology, and we have our own infrastructure, right? So currently, that's how we can provide this APIs as a service, including fast GPU computation and so on, and scalable. Now we are with around 1,000 cores and 1 petabyte of storage for now. And we just received a very nice funding, and we already received these machines, which are in the top 500 of the computers in the world that will be used mostly for astronomy and the other projects that we had in the lab. So with this kind of infrastructure that we could build in Brazil, we expect to have, I don't intend to do that, just to let you know. I don't intend to train an LLM from scratch, but in principle, we could train a 7 billion parameter LLM in around 1 to 2.5 months, right? With the additional 1,088 GPUs that are over there. We are generously funded for the next couple of years, so we are happy with that. So if you'd like to know more about what we have been doing with this LLM and foundational models in terms of TVS, there is this channel in Robin Slack if you are part of this community, and if you want to be part of this community. The telecoms now are not happening because we are working on the AI white paper for TVS, but we have this meetings, and you are welcome to join. Just the summary. So AI can do more for classification. Agentic AI can encapsulate contextual information. There are many models going on, and well, AI can help you get informed decisions. That's the most of the thing. And if you want to see the demonstration videos, this is our 2 demonstration videos that I don't have time to show, with the foundational models API and the ABC and the LLM report. And we are only able to do this because we have this local great infrastructure, and we can develop our own LLMs and RAGs. So thank you very much. I already talked too much.
Thank you, Clesio. Great computing power. Go ahead, right there.
Hi, Clesio. Great talk. Thank you very much. So I was wondering, so you're building this agent, or you have already built it?
Yes.
You already built it. So how do you evaluate how good the performance of the agent itself is?
Well, for now, we are stress testing it, so this is one of the examples. If you look at the video, you see that the fit fails. It's a very poorly constrained, and the agent got it. And they say, oh, see, this is the wrong way of making the fit. I'll do it the other way. So for now, we are just showing to humans and trying to make some quality assessment of what it's doing.
So humans evaluate the agents.
Yes.
Okay, thanks.
Any other questions? Yeah, this one bit, and then we'll come to you.
Over here. Hi. Thanks. That was a great talk. I'm curious why you need the HPC. Is it because you're training your own models, or is it because of the inference that you're doing to understand all the questions?
Why I need ABC, you mean?
HPC.
HPC. Well, yeah, we are training our own models, including the LLMs, and we run this. We expect to scale this over millions of trials every night. That's why we need HPC.
You're retraining it every night.
Yes.
Well, thank you. That also answered the other question that was going to come apparently. So let's thank Plesio again.
Thank you.